Hi everyone, this video is on question 9 of exercise 9H. So we have this function len y squared is equal to half x len x minus 1, and we want to find the derivative, we want to find the gradient of the curve where x is equal to 4. So in questions like this, we always differentiate the equation and then substitute the coordinates of the point into the derivative equation in order to find the gradient at that specific point. And it's an implicit differentiation because it's written implicitly, and we have len y squared is equal to half x len x minus 1. So if we want to differentiate len of any function, we basically use this. So for example, if you have len f of x, let's say g of x is equal to len of f of x, so you have a function inside len, and g dash x, which is its derivative, is equal to the derivative of the inside function, which is f dash x, over the function itself, f of x. So I have different videos on this topic, and you can watch them if you think you need to revise. So in this case, len y squared, so y squared differentiates to 2y, and its denominator is just the function itself. The function is y squared. So that's the derivative of len y squared. But since it's implicit differentiation and y is the dependent variable, so we'll have dy dx as well. It just always, we have dy dx when we differentiate implicitly. Now on the other side, we have half x times len x minus 1. So it's the product rule. I'm going to write the first function, which is half x, times the derivative of the second function. So the second function again is ln, and so its numerator is the derivative of inside, which is just 1, and the denominator is the function itself. So this is the first half of the product rule. The second half says differentiate the first function, so half x differentiates to a half, and this times the second function, len x minus 1. This is the derivative, and also on this part we can simplify this y with the power of the denominator. And now we can rearrange this. So one thing we can do is that just keep the 2 over y on the left hand side for now, and then here take a factor of a half. So we have x over x minus 1 plus len x minus 1. And now we can divide both sides by 2 over y. So we'll get dy dx is equal to y over 4 times x over x minus 1 plus len x minus 1. Okay, this is dy dx in terms of x and y, and we now want to find a gradient. So normally at this point we just substitute the x coordinate and we get the gradient, but here we have the y variable as well, so we can't just do that because we need some value for y, and that can be found by just simply substituting this x coordinates into the function, into the the equation of the curve, and that gives you the y coordinate, and then we can substitute that into dy dx. So I'm going to do that here when I'll write with a different color just to show that it's not part of the differentiation step. When x is equal to 4, we are going to have len y squared is equal to a half times 4 times len 4 minus 1, which is just 3. And let's see what we get. So len y squared is equal to 2 len 3. Now at this point, what we can do is that we can first simplify the 2, because remember, this is y squared, so the power can basically be taken out and written as a coefficient. So 2 len, this is one of the properties of the logs. 2 len y is equal to 2 len 3. At this point, we cancel out the 2's, and we only have len y is equal to len 3. And at this point, we raise, so we have basically the exponential function of len y is equal to e of len 3, which means y is equal to 3. So now we know the value of y is 3. So we are at a position to substitute 3 and 4. So 4 is the x coordinate, 3 is the y coordinate, into divide the x to find the gradient. So now the point P, let's say, because there is no name given to it, has coordinates 4 and 3. And now we can find the divide dx, the value or the gradient. Divide dx is equal to, so y is 3 over 4 times x is 4. So 4 over 4 minus 1, which is 3, plus len 4 minus 1, again 3. And now just, this is basically the value of the gradient, and we can simplify this if you like. So we are going to get 1 plus 3 over 4 len 3. And this is the gradient at the point P. Okay, so thank you for watching, and make sure to subscribe. I'll see you in the next video.